Okay, so 3.3, linear equations in two variables. We want to be able to identify linear equations in two variables, intercepts of the coordinate axes, so your x-intercept, y-intercept, horizontal and vertical lines as well. Okay, so that's what we want to be able to do. So let's start out with the definition. A linear equation in two variables, say x and y, is an equation that can be written in the form ax plus by equals c, where a, b, and c are constants and a and b are not both zero. This form of an equation like this is called standard form. So again, this form here is called the standard form for an equation of a line in two variables. So what you have now is you have your standard form for circles. You have your standard form for linear equations in two variables. Let's do an example. We want to determine if the following equations are linear. We want to determine if the following equations are linear. We have 9x plus 4 times the quantity y minus x equals 3. If this equation is linear, we should be able to have it in standard form. Notice that how many variables really appear? 2. What are your variables? X and y. Good. Are there any combinations of x and y? Where's a combination of x and y? Do we have a combination of x and y? When you hear combination in math, what do you think of? Say it again. Y and x together, right? So like you're multiplying them, right? We don't see a product, so there are no combinations, right? Okay, so let's look at this example and see what we have. We have 9x. We can distribute the 4 to get plus 4y minus 4x equals 3. And then what can we do? That's right, combine it, right? So you have the 9x minus 4x is what? 5x, good, both of you. 5x plus 4y equals 3. There's nothing else to do. Is this a line? Yes, absolutely, because it's in standard form. We're able to do that. So the answer is yes here. Okay? Questions? So we're determining if the following equations are linear. That's what we're doing. So let's look at part B. We have 3x plus x times y equals 2y. Is that linear? No, because you see a combination. Absolutely correct. So the answer is no here, because you have an x times y right here, means that this is impossible. It cannot be linear. Remember, your linear equations have the form ax plus by equals c, where a, b, and c are numbers. So no, because it has a product. X times y. Okay? C. We have the quantity x plus y squared minus the quantity x minus y squared equals 1. As it is given, is it a line? What would help us determine if this is a line? I can't hear you. What? Can you talk louder?
Some numbers.
What do you mean numbers?
You said whatever the term, if it was a line or not.
Okay, so you said if we have numbers for x and y, that would help. But we don't have that. So what else can we do?
Can we combine them?
Combine what?
Like wouldn't x plus y cancel out x minus y?
No, because you have those are quantity squared. Multiply what? That's right. You expand and multiply it. That's absolutely correct. You have the quantity x plus y squared minus the quantity x minus y squared equals 1. So we're going to multiply x plus y times x plus y, subtract x minus y times x minus y, and set that equal to 1 to see if we can simplify somehow to get a line, to see what exactly we have. So let's do that. So we have the quantity x plus y times the quantity x plus y minus the quantity x minus y times the quantity x minus y equals 1. So then you use your FOIL method to expand each one. So the first one comes out to be this product here, when you use the FOIL method, gives us x squared plus 2xy plus, what's your last?
Y squared.
Good, plus y squared. Minus the quantity x squared minus 2xy plus y squared, all of that equals 1. And now we distribute our negative here. So now we distribute this negative to get x squared plus 2xy plus y squared minus x squared plus 2xy. What's the rest?
Is that plus
You said plus minus y squared. Why? Because we're distributing the negative. Good. Equals 1. Now what happens on the left-hand side? Combine like terms. What happens?
The x squares cancel,
X squares go away.
and you combine the two xy's.
Combine the 2xy's to get what?
4xy.
What happens? What else?
The y squares cancel.
The y squares cancel out.
4xy equals 1.
So 4xy equals 1. Is this a line? No, not a line. So the answer is no, because it has a product.
I have a question.
XY.
If there are exponents involved, will it ever be a line?
Say it again.
If there are exponents involved, will it ever be a line?
Exponents other than what number? If there are exponents other than 1 involved, then it's not linear. But notice here, we had to expand it, and those square terms canceled out. So it's helpful to expand to see what happens. Now, if you ended up with an x squared here, it's not linear, right? Because it's a quadratic at that point. It involves a square term. Good question. Yes?
It can be linear with one variable, right?
Yes. With a variable, with one variable with an exponent of 1. Yes, it can. You can have a vertical line, you can have a horizontal line.
So, but in this situation, because it was asking to determine if it's linear, would, even if it just has one variable, that's
Would it be linear? Yes. Is it a linear equation in 2 variables? No. But technically you could put a 0 times the variable, so yes, it's linear. It's linear. Good questions.
You said if it's squared, it can't be linear.
Because a squared is what type of,
Quadratic.
it's a quadratic. What other questions? Okay, so let's look at another one. Part D. And I always put extra problems. It's not necessary for all of these. It's just so you can get a feel for it. So part D, we have x minus 3 equals 4x plus 17 over 5. If you want to eliminate the fraction, you can multiply both sides by what? 5. Very good. So do that. So we'll have 5 times x minus 3 equals 5 times the quantity 4x plus 17 over 5. The 5's cancel on the right to give, and then we simplify, distribute this 5 here. We get 5x minus 15 equals 4x plus 17. And then we simplify. Okay? So when we simplify, moving everything from the right to the left or the right to the left with or from the right to the left or the left to the right, whichever one you prefer, I'm going to subtract 4x and 17 from both sides to get x minus 32 equals 0, which means x equals what? 32. So the question is, Lisa asked, this question, is this a line?
Yes.
Yes, it's a line. Has one variable, right? It's a line. The exponent is 1. It's a vertical line. It's a vertical line. So to be clear, this is a vertical line. So is it a line? Absolutely. The graph of it looks like this going through 32. So technically, the coefficient of y is what? Is there a y there? No. So what's the coefficient of y? 0. Very good. So the answer is yes. Coefficient of y is 0. So yes, it's a line. Questions?
Just for clarification.
Yeah?
If it was y equals to 32 and the same thing, but the line would go through the y-axis.
Would it go through the y-axis? It will go through the y-axis, right? What number? 32. It will be a horizontal line. So if you ended up, different color means we're answering a question at this point. So if you have y equals 32, that is a horizontal line going through 32. Good questions. Other questions? Can you talk a little louder?
You can solve any equation dealing with two variables and slope intercept on.
You asked, could you solve a linear equation in two variables? Putting it in slope-intercept form? Are you talking about finding the solutions to it? I can't hear you. What will be? If you have it in slope-intercept form, yes, that's a linear equation too. It's just a different format. So yes, it's okay. And that's what we'll talk about in the next section. We'll go through slopes in slope-intercept form. We'll do all of that. So yes, absolutely. What other questions do you have? Okay, all right. Any point where the graph intersects the x-axis is called a what? X-intercept. Very good. It's called an x-intercept. It's called an x-intercept. These are of the form c comma 0. So if it crosses the x-axis at the point C, that point is c comma 0. That's your x-intercept. Any point where the graph intersects the y-axis is called a what? You got it. It's called your y-intercept. These are of the form 0 comma c. So in other words, when you cross the y-axis, like so, that point there would be 0 comma c. So now let's go through example 2. In example 2, we want to find the x and the y intercepts of the given equations, and we want to sketch the graph. We want to sketch their graphs. So you have y minus 3x equals 9. There are a few ways you can do this. As Arquez was saying, you may want to put this in slope-intercept form if you know that already. If you don't, you can do an XY chart, right? And one thing to notice here, your x-intercept always has y equals what? 0. So if you want to find your x-intercept, you set y equal to 0 and you solve. Your y-intercept always has x equal to what? So if you want to find your y-intercept, you set x equal to 0 and solve. Okay? So your x-intercept, to find your x-intercept, we're going to set y equal to 0, and we're going to solve. So we'll have 0 minus 3x equals 9. That gives us negative 3x equals 9, or x equals what? Divide both sides by what? Negative 3 to get 9 over negative 3, which is negative 3. Very good. So the point for your x-intercept is negative 3 comma 0. Very good. Let's find your y-intercept. How do you find your y-intercept? Can't hear you. Set what now? Talk loud. You said what? Set x be equal to 0. Good. Set x to 0. So we get y minus 3 times 0 equals 9, which means y, what else do we have now? Minus 0 equals 9, which means y equals? What does y equal? 9. So what's the point? 0, 9. And what else do we have to do? We found our x-intercept. We found our y-intercept. Now what do we have to do? Sketch the graph. You got 2 points. Sketch it. You got the x-intercept. You got the y-intercept. So you sketch negative 3. That's your negative 3, 0. That's your x-intercept. And 0, 9 is your y-intercept. That's your line. That's your line. What questions do you have? Do B. Do part B. Part B, you have y minus 2x equals y minus 4. You have y minus 2x equals y minus 4. Take a couple of minutes and find the x and the y intercepts, if any at all, and sketch the graph. So to find the x-intercept, you set y equal to 0. Whenever you do that, we have 0 minus 2x equals 0 minus 4, which means negative 2x equals negative 4. Divide both sides by what? Negative 2 to get x equals, what's your point? 2 comma 0. Good. Your y-intercept, you set what equal to 0? Good. Set x equal to 0. And we solve. So whenever we do that, you get y minus 2 times 0 equals y minus 4. That gives us y minus 0 equals y minus 4. You can subtract y from both sides to get 0 equals -4, which is false. This is false. So that's a false statement, which means that you have the point 2, 0 and the line through that. So you have a vertical line. What questions do you have? So I've incorporated this in our examples, but we need to formally define what a horizontal line looks like and what a vertical line looks like. So let's do that on the next page. But we've already incorporated that through our examples. Okay? Horizontal lines are of the form y equals a, where a is a constant. So for example, if you have y equals 2, the graph is what type of line? Horizontal line going through y equals 2. So horizontal going through y equals 2. Okay? Vertical lines are of the form x equals a, where a is a constant. So we have x equals -1. That's a what kind of line? Vertical going through where? The x-axis for what number? -1. Good. So you have this vertical line. What questions do you have? Okay. So now we're going to move on to 3.4. We talked about horizontal lines and vertical lines. So let's go ahead to 3.4, where we're talking about slopes and forms of linear equations. Okay? So this is 3.3.